We're studying control laws for self-propelled agents, where the only input is a shared rotation command that rotates every agent by the same rotation matrix. Imagine n radio-controlled cars all controlled using the same radio frequency. When you command one car to move along a certain trajectory, all other cars follow a trajectory of the same shape, starting from their initial positions and rotated according to their initial heading. Each pair of cars can collide only in the regions shown by gray disks. In 2D, any two such agents can only meet at one place in the workspace. For 3 agents, there are 3 possible rendezvous locations. By knowing these rendezvous locations, we can plan collision-free trajectories. Applying a constantly rotating input causes the agents to orbit. A self-propelled agent in 3D is defined by the offset of the thrust vector from the global coordinate frame. Unlike in 2D, applying a constantly rotating input does not return self-propelled agents to the origin. Our paper presents an open-loop input that steers all spheres back to the origin. We can use linear programming to steer 3 spheres to goal positions. We also design closed-loop feedback controllers to steer 3 spheres to goal positions. We prove that we can control no more than 9 position parameters. However, we can use these 9 parameters to cause 4 spheres to rendezvous, but they can only meet at one position. The variance of n agents can only be reduced to a value determined by the initial condition. An interesting thing happens if the thrust vectors are independently randomly perturbed each control period. If we can quickly measure the new thrust vector orientations, we can steer many more than 3 agents to goal positions. This model may have applications to magnetically steered self-propelled particles, such as Tetrahymena piriformis, a single-celled microorganism. These cells swim in straight lines at an angular offset from the magnetic orientation. They often have different offsets, which could enable steering the position of multiple cells.